Alright, so chapter 9 is focusing on the linear programming. Okay, what are we looking at here? We're looking at an inequality. Okay, what is an inequality? It's a range of answers. Okay, with linear programming, you're not looking at one inequality, you're looking at many. Okay, so here I've got two lines. Okay, these two lines could be representing different inequalities. And if I'm looking at this side of the line, okay, which area under the lines represents or satisfies all of those lines? It's this, do you agree? Okay, that part. Okay, that part represents what? The feasible region. Okay, it's where the answers may lie. Okay, that's what you're doing with linear programming. This you probably remember from high school. Okay, feasible region. Okay, feasible region is what? The area under the system of inequalities. Okay, where you're meeting all the requirements. Okay, so if I'm looking at under the lines, okay, this area here meets the requirements. Okay. Alright, so there are some examples that we can look at, okay, in terms of linear inequalities. Okay, so let's look at one example. Okay, x must be greater than 0. So where is that? Here's x. If it's greater than 0, it must be above. Okay, or not above, actually, it should be this way. Okay, that should be x equals 0. X greater than 0. Right, that's the x-axis, this is the y-axis. Okay, the y is bigger than 0, that's this side. Okay, so y bigger than 0, x bigger than 0. I want amounts on that side of the lines. Okay, which equations do you have? You've got two. Okay, what do I do with those equations? I need intercepts. Okay, so let's look at the first one. There's the first graph. What is the y-intercept for the first graph? How do I work out a y-intercept? Make x 0. Good. Okay, so solve for y. So I'll have 0. 0 plus 2y greater than or equal to 15. Okay, so y greater than or equal to 7, 5. Okay, now I know what the y is. Okay, what else do I need? I need an x-intercept. How do I find an x-intercept? Make the y 0. Okay, so 3x greater than or equal to 15. X greater or equal to 5. Okay, so now I've got the y and the x-intercepts. That's great. Okay, now I need to do the same thing for this one. Okay, so y-intercept, make x 0. Okay, so if x is 0, I'll have 0 plus 9y greater or equal to 36. Okay, so y greater or equal to 4. Right, that's the y-intercept. Right, now I need to do the same thing for the x-intercept. How do I get the x-intercept? Make y 0. So 6x greater or equal to 36. X is greater or equal to 6. Right, so there's my intercepts. Right, so now I can plot this on my graph. Okay, 4 and 6 would go something like that. Okay, there's 4, there's 6. Okay, and then I would draw the other line. Okay, which would be something like that. Okay, there's 5 and there's 7, 5. Alright, so now I need to look at which side of the line do I lie. Okay, in terms of possible answer. Okay, and how do you do that? You need to test. Okay, so the easiest point to test is that point. Why? It's 0, 0. It's the origin. Okay, so if I put in a 0 here, and I put in a 0 here, okay, what is 0 plus 0? 0. Is 0 bigger than 15? That's false. Okay, so do you agree I can't have any amount on that side? Okay, if I'm looking at the red line, I must look at things on that side of the line. Does that make sense? Okay, because 0, 0 isn't a possibility. 0, 0 makes a statement false. Okay, if I take a big number, let's say 100. If I make this 100 and 100, what's 100 times 3? And 100 times 2? 200. 300 plus 200 is 500. Is 500 bigger than 15? Yes. Is that true? Yes. Okay, so can I have point number brackets 100, 100?
Yeah.
Yes, I can. Does that make sense? Okay. Alright, so now let's look at the other line. If I put in 0 here and 0 here, what's 0 plus 0? Is 0 greater than 36? No, so I must also have amounts on that side of the green line. Okay, so where do you meet the system of inequalities? Okay, it's here. Okay, all of that, okay, is the feasible region. Okay, because I'm on that side of all the lines. Okay, does that make sense? Okay. Alright, there's a few more examples here. Okay, again, I want to do the ones in your assignment. Okay, these are examples that you should do as practice. Okay, these are some of the good examples that I've taken from the actual textbook. Okay, so if you've got some time, go look at page 487. Do as many of those questions as you can. Okay, the solutions are there, and they're used, or they're there for you to practice. Okay, is that alright? Okay, this one also, practice. Okay, then we've got nonlinear, which is not straight. Okay, so that's nonlinear. Okay, maybe we can do it. I'll leave the calculus for later. Okay, just so we can look at the assignments. Okay, so if I look at this, if something is nonlinear, what does that mean? Correct. Okay, so we're looking at a curve. All right. So do you remember the straight line? Okay. What power do I have here? Yes, 1. Okay, all the bases have an exponent of 1. 1 here, 1 here, 1 here, 1 here. They all have a 1. The most important variable is the x. The x will change the function from non-linear or from linear to non-linear, or linear to non-linear, linear to non-linear. Okay.
X the only one.
Yes, x. So if I make x squared becomes non-linear. Okay, not straight. Okay, because you're raising the x, which is the independent variable, by an exponent. Okay, so what do these functions look like? They're straight lines. Okay, y equals mx plus c. Okay, here's an equation. Y equals mx plus c. What's the y-intercept? Yes, the y-intercept will be where x is 0. That's how you calculate it. Good. Okay, what is the x-intercept? Okay, you make y 0. Okay, so in this particular question, the y-intercept is what? 10. The x-intercept is what? 0 equals 5x plus 10. Okay, so minus 10 equals 5x, x equals minus 2. Okay, so that's your x-intercept. That's your y-intercept. Is that okay? Okay, good. Right, so how would I draw this particular graph? Remember, drawing graphs don't change. So what did we discuss before the break in terms of drawing a graph? What do I need to draw a graph? That's for a straight line. I need points, exactly. If I've got enough points, I join the dots and I get a graph. Okay, so how do I work out TR here? Total revenue. I need to substitute Q in. So what's 0 squared? Times 2? So 50Q minus 0 is 50Q. Q is 0. So 50 times Q is naught. So that's naught, naught. Okay, so there's 1 point. Okay, 5. 5 times 50? 250. Okay, 5 squared is? 25 times 2 is? 50. So 250 minus 50 is? 200. Okay, 10 times q is? 10 times, no, sorry, not q. 50 times 10. Q is 10. 500. 10 squared is 100. Okay, 2 times 100 is 200. So 500 minus 200 is 300. Okay, try to do the rest. 15, 20, and 25. Now, grab the calculator, quickly substitute and solve. So what do we get for the last three? 15? Should have got 300 as well here, right?
300, 200, 0.
Yes. Okay, so what does that graph look like? Well, there's 0, 0, there's 0, 0. There's 200, there's 200. Here's 300, there's 300. So the graph does that, yeah. Okay, it's a curve. Alright, so if I look at this curve, it's non-linear. It's non-linear because I have that. A power greater than 1. Okay. Alright, so what happens when I have roots? What is a root? A root is your x-intercepts. Okay, we're not looking at square roots. Okay, square roots and squaring. Okay, those are exponents. Okay, here we're looking at the roots of an equation. So the roots of the equation mean, well, you are square rooting in a way because you're trying to determine what x is. Okay, so if I square root this, I'm going to get what x is. Alright, so if I'm looking at roots, 5x squared, what would 5x squared be? X would be plus minus 0. Okay, so x is 0. Those are the roots. Okay, so are those roots positive or negative? They're at 0. So what does the graph look like? At 0. Okay, that's the turning point. Okay, so when looking at roots, roots arise where the x-axis. Okay, do you have multiple x's or don't you? Okay, here I don't have multiple. I've just got one. I've got an x value of 0. Okay, and that's the curve. Okay, what happens here? Well, let's solve for x. 2x squared equals 32. X squared equals 16. X equals plus minus 4. Okay, so what would that look like? It'll look like this. Okay, there's a minus 4 and there's a 4. Okay, so those are the roots, i.e. the values of your x. Okay, in terms of the intercepts. Okay, what happens if I have something like this? 2x squared equals minus 8. Okay, x squared equals minus 4. Can I square root x squared? Yes. Can I square root a negative number? On your calculator, type it in. Root minus 4. No solution. Okay, and the reason for that is, here's the point. Okay, so this graph had 0. This graph had 4 and minus 4. This graph does something like this. Okay, there are no x-intercepts. Okay, because the line doesn't cross the x-axis. Okay, does that make sense? Okay, so you get real roots, you get non-real roots. Okay, we're looking at roots, i.e. values for x-intercept. Okay, makes sense. Alright, here's your equation for a non-linear function. Okay, this you probably recall from matric. Okay, so what does the c represent?
The y-intercept also.
Correct, it doesn't change. Yeah, still the y-intercept. Okay, the a and your b will change the shape of that particular parabola. Okay, so when I look for roots, if you can't factorize, how's your factorizing? Okay, if you can't factorize, then always use the equation. Okay, because that you can plug into the calculator. Okay, if you plug that into the calculator, it'll give you the roots. Okay, so here's an equation. X squared minus 6x plus 5. Okay, if I factorize, I can do this. X minus 5, x minus 1. Okay, a negative times a negative gives me a positive. Okay, this minus that gives me minus 6. You didn't like that? Okay, so if you don't like it and you can't do it, or you're struggling to do it, then use the formula. Okay, because here, what will I get as x? Here, x will either be 5 or x will be 1. Okay, if I plug that into the calculator, I'll get the exact same answer. Have a look. X equals minus, what is b in this equation?
6, minus 6.
Minus 6 plus minus square root bracket minus 6 squared minus 4. What is your a and your c?
5.
Correct. Over, what's your a? 1. Okay, so if you neaten that up, okay, this will be 6 plus minus square root. Okay, what is 6 squared? 36. Minus 4 times 5 is? So 16. Okay, 36 minus 20 is 16. Okay, over 2. Okay, what is root 16? 4 plus minus 4 over 2. Okay, so I've got two options. 6 plus 4 over 2 is what? 10 over 2 is 5. Okay, or 6 minus 4 over 2 is what? 1. Is that the same answer? Yes. So whether you do it that way or this way, it doesn't matter. Okay, make sure you get the right answer. Okay, you can decide which way you prefer. Okay, but if you do use the formula, you need to remember the formula because you won't be given a formula sheet. Okay, good. Alright, giving you a few more examples. Okay, again, have a look at these when you've got some extra time. Okay, there's a lot of examples that you can do in your textbook. Okay. Alright, let's have a look at, there we go. Okay, so I'm skipping a few slides. Those are ones that you can practice. Okay, if you have a problem, then let me know, and then I can always send you workings and we can discuss it. Okay, let's look at this. Okay, so do you remember this from slide 6? Yes. Okay, this represents what? Total revenue. Okay, is there a maximum revenue here? What does the maximum mean? Highest point. So where is my highest point? Over there. That's the maximum. Okay, so when looking at a maximum, the highest point is that point over there, right? Okay, so is there maximum revenue? Yes. Where does the maximum revenue occur? At the highest point, which we know is 12, 5. Okay, half of that is 12 and a half. Okay, how do you find the maximum or the minimum? X equals minus b over 2a. Okay, or you can use the first derivative. Have you done calculus? Okay, so do you know what the first derivative is? Sort of. Okay, we'll see it later on. Okay, I'll come back to the slide and we'll use the other method. Okay, but for now we can't because we don't know any calculus. Okay, so what is minus b? What's b in this question? Minus 50. Do you agree? What is a in this question? Minus 2. So 2 times minus 2. Okay, what is minus 50 over minus 4? Positive 12.5. That's how you get the x value of what? The highest point. Okay, the question is calculate the maximum TR. So how do I get the maximum TR? Work out the y value, which is TR, for the x value, which is quantity. Does that make sense? Okay, so max TR equals 50, open brackets, 12, 5, close brackets, minus 2, open brackets, 12, 5, squared. Okay, on your calculator, quickly type that in and see what you get. $312.5. Okay, and that would be the maximum revenue. Okay, i.e. that point over there. Right, so the value or the coordinates of that point would have been 12, 5 and 312, 5. Okay, that's the coordinates for that maximum. Okay, is that right? Great. Okay, and then there's a note here about price elasticity and demand again. Okay, so if I'm looking at equilibrium price, total revenue must be the same as total cost. Okay, these are just some application that we can look at. Okay, there's some more examples from the textbook, and then just a note here about the nonlinear. Okay, so this is the last bit that we can quickly wrap up assignment 1. Okay, so nonlinear functions. If something's nonlinear, it's not a straight line. Okay, this is an exponential function. Okay, if it's an exponential function, you've got an exponent. Okay, but the same rules apply. If I had to draw the graph, I need to substitute into the equation. Okay, so if x is minus 2, what would y be? Y would be 2 to the power minus 2. What's 2 to the power minus 2? No. Work it out on the calculator. 0.25. It's a quarter. On the calculator? 2 to the power minus 2. Okay. 2 to the power minus 1. It's a half. Okay. 2 to the power 0. Anything to the power 0 is what?
1.
Yes. Okay. 2 to the 1, 2. 2 squared, 4. 2 to the 3, 8. 2 to the 4, 16. 2 to the 5, 32. Okay, so have a look. What's happening? It's getting bigger and bigger, quicker. Okay, that's an exponential function. Okay, the intercept is 1. Okay, for an exponential function. Okay, right, there's a few more examples here that we need to look at in terms of rules. Right, we spoke about the rules earlier. Okay, what happens when I multiply exponents? You add them. So what will the answer be here? Correct. What happens if I raise an exponent by an exponent? X to the 15. Correct. Is that okay? Right. So those are all the rules that you've got in terms of indices. Okay. This is important. Okay, the log. There we go. Okay. So logs. All right. How do I do logs? I need to remember a simple calculation. Okay, this is a simple calculation. 2 to the 3 equals 8 can be represented as log base 2 of the answer, which is the exponent. Okay, that's what I always write down whenever I have a log question. Okay, whenever you have a log question, you jot down something simple and easy to remember, then you can convert and change it around and do whatever you like with it. Okay, but you need one simple equation before you can do the actual log. Okay, is that alright? Okay, yeah. Alright, supply and demand, that's fine. Okay, and then this is the calculus, slope of the curve. Okay, we'll stop here. Alright, because that's the calculus. Alright, so let's pause. Okay, let's go back to the assignments.